This is worksheet 8.4, and we're looking at the section here where we need to decide which method is most appropriate. We have squaring, square rooting, quadratic formula, completing the square, or factoring. In some of these problems, there are multiple ways to solve the problem, but it's up to you to decide what you think is most appropriate. We're going to do 10, 11, and 12, and for each we'll first decide on a method and then solve. In number 10, we have a quantity squared. If you have a quantity squared, one of the methods you can use is square root. So I'm going to just label this SR for square root. So let's solve number 10. What we're doing here is we're undoing the operations in the equation. So you should think about what makes most sense to undo first. We have a 4 times this quantity, we have a minus 3. If you were to divide everything by 4 first, you would get some fractions here. So let's try adding 3 first, and then dividing by 4. Now we can take the square root of both sides. So we get x minus 1 equals, and this could be plus or minus root 7. If we add 1 to both sides, then our solutions are 1 plus root 7 or 1 minus root 7. All right, let's look at number 11. All right, here, looking at this problem, the square root method wouldn't be so useful because if you took the square root of terms that are being added or subtracted, there's no way to simplify that. The squaring method wouldn't be appropriate because we don't have any radicals. Quadratic formula could work. These are pretty large numbers though, so you may want to think twice about using quadratic formula. Completing the square. You could attempt to use completing the square, but if you factor out the a value, you're not going to have any nice values here once you factor out a. So let's try this last method, factoring. So let's check first if it's even factorable. So on the top here, we need to put 25 times 9, which is 225. And on the bottom, we have negative 30. So this could be negative 15 and negative 15. So if we go ahead and try to factor this, I'm going to bring down the 25x squared, and I'm going to bring down the 9. And I'm going to split the middle term using the values in my diamond here, negative 15x and negative 15x. GCF here is 5x, and GCF here is a negative 3. So my factors are 5x minus 3 and 5x minus 3, so two of the same factor. That means 5x minus 3 is equal to 0, or x is equal to 3/5. All right, lastly, let's look at number 12. We have a square root. We have a radical in this problem. Anytime you have a radical, in order to undo that radical, you have to square both sides. So we're going to call this squaring. We used factoring on number 11. So on number 12, if we square both sides, we can get rid of the radical. So I'm going to square the left side and the right side of the equation. This gives me x squared minus 4x plus 4. Squaring a radical just gives you what's inside the radical, and the right side is 4. Subtracting 4 from both sides, we get x squared minus 4x equals 0. And you still have a quadratic here, so you are going to end up having to factor. So here, if we factor this, we get x times x minus 4 equals 0. That means either x equals 0 or x minus 4 equals 0. So our solutions are x equals 0 and x equals 4. You should always check, so plug these values back into your equation and just check to make sure that they both are valid. 0 plugged into here, square root of 4 is 2. 4 plugged into here, 16 minus 16 plus 4 is 4. Square root of 4 is still 2. So both of these end up working.